good morning, everyone. Thank you, Becca, for kicking off the day with a wonderful talk. I want to start with a little bit of interactivity, nothing too crazy. I'm not going to make you stand up or anything, but raise your hand if in the last year you've built an application or any sort of project without actually using any libraries and just native web stuff. Okay, I see 2 hands. That's about what I thought. The reality is nowadays, building with libraries and stuff like that has become so common that most of us can't really remember what it's like to do it without it, what it's like to develop without having to install a bunch of stuff. And personally, I don't really think that this is that bad of a thing. I think it means that we're spending a lot less time rewriting code and solving problems that have already been solved by other people. And so on the whole, I think it's a really good signal. However, I think it's bad because it's created distance between ourselves and the web platform. We spend a lot less time thinking about what our browsers are actually capable of doing, and instead just relying on solutions that other people have developed for us. And so this talk that I'm giving today is going to be focused on rediscovering the joy and excitement and fun of working with those things that are built into the browser, or web APIs, as I like to call them. And my goal in this talk isn't to give you a whole bunch of super practical things that you can immediately apply to your day job, but rather give you some ideas about how you can start studying these APIs to transform the way you think about building and developing applications for the web. A little bit about myself. My name is Trent Willis, and currently I'm a staff software engineer at Netflix. And I got into web development during kind of the heyday of jQuery. And so even at that point in time, we were using libraries, but much fewer. Most of the tutorials that I was reading when I was getting started were things related to, working in TextEdit or Notepad or maybe Sublime Text if you were fancy, and then serving jQuery into your website through a CDN rather than having to use NPM or Yarn or anything like that. And so I have very nostalgic feelings for those times of web development where things felt a little simpler. And so that's kind of what motivates a lot of my personal projects these days and what motivated this talk. And so before diving into the bulk of this talk, we should probably take a step back and talk about what exactly is a web API. Well, a pretty simple definition is that a web API is any interface that's built into your browser. Those are often accessed through JavaScript, but could also come in the form of HTML or CSS interfaces that you use. But as we all know, these things don't always get added to all browsers at the same time, and so they may not necessarily be available in every single browser. Though nowadays, with kind of the ubiquity of Chromium as the source for a lot of browsers, the consistency is a lot better than it used to be, though there still are some deviations between Firefox and Safari and other smaller browsers as well. And we'll talk about that a little bit more later. And these APIs are usually governed by standards, most often developed through the Web Hypertext Application Technology Working Group, otherwise known as WHATWG, though some of them also come through the ECMAScript TC39 committee, who kind of governs and oversees the JavaScript standards. And these standards eventually make their way to all browsers. But most developers, we don't spend our time reading web standards. If you've ever read a web standard document, it's pretty dense, very technical, lots of jargon, really hard to understand. But looking at those standards can really help us discover new areas and new realms of web development, because these standards are being developed because people are pushing the boundaries of what the web can do, asking for new features to support new use cases. But as a developer, we most often encounter these in the form of the APIs that actually wind up in the browsers and not these documents. And so I want to talk about an example of how we can start to see new possibilities on the web by talking about a specific API that's actually been around for a number of years now, called the message channel. Now, quickly, raise your hand if you've ever heard of the message channel API. Okay, four or five people? Pretty good. Essentially what it does is it allows you to take a script that is executing in a certain execution context, meaning a website, maybe an iframe, or maybe a web worker, and then communicate with another execution context. And so another website, another iframe, or another web worker. And if you come across this for the first time, you might ask yourself, okay, what is the use case for this? Why would I actually need that? I've never needed that in my work before. Well, the reason it exists is to enable very interesting architectural patterns on the web. So for instance, one common way that you want to use this is to get things off of the main thread and keep them off of the main thread. So if you have a website, for instance, and that website has a web worker, it's pretty easy to communicate back and forth via the web worker's normal post message API. If your application grows in complexity, though, and you start introducing other workers, in order to communicate between the two of them, you have to post things back to the main thread and then over to the other web worker, which means that you're essentially having to do a double transfer, which winds up costing a lot in terms of performance and execution speed of your code. So if we could get rid of that transfer and instead be able to just communicate directly between those two web workers, it would save us a lot of overhead. And so that's what the message channel API allows us to do. And the really awesome thing about this is that now we can do a whole bunch of offline processing and completely avoid having to touch the main thread of our web application altogether, which can provide a smoother and more seamless experience for our users. Another reason that you might want to use this API is to decouple execution contexts. And this is, again, best explained with an illustration. So if you have a website and you're using a sandboxed iframe to execute some code, because iframes have terrific sandboxing capabilities, this is wonderful because you can allow users to write custom code and execute it safely on your website. But the problem is that both of these things actually run in the browser's main thread, which many folks aren't aware of. And so again, in order to prevent blocking and introducing jank into your website, you would need to use a web worker and put it in a different thread. The problem now is the same problem that we ran into before, where you have this nice non-blocking execution context, but in order to get anything to it, you have to post it into the iframe and then post it into the web worker. But if you send a port from the message channel into the iframe, that iframe can actually shift it down into the web worker, and your website has no knowledge of this. It doesn't care. It just sends messages through the channel, and then it can be handled wherever the iframe wants it to be handled. And so this is a really kind of niche idea that a lot of folks wouldn't need to use in their applications, but it's something that I've encountered in my own personal work. And so we actually wrote a small little library that we call Sandybox that allows you to execute any user-generated arbitrary function safely in a sandbox while also not blocking your main thread. So that way you don't have to worry about your users writing performant code, and instead you just never have to worry about it. And so you can find this on GitHub as well as NPM if you're at all interested. But the whole reason I bring up this example and this idea of the message channel API is to talk about how by delving into these web APIs that most folks aren't familiar with, we can actually learn a whole lot of things about the web platform. Right? Along the way, we weren't just talking about the message channel API. We were also talking about message ports, which are part of the message channel API. We talked about iframes a little bit, web workers, shared workers. You could go a little further and start talking about broadcast channels, which are similar to message channels, but allow you to communicate between different browser tab instances if they're on the same domain. We could talk about weblocks, which allows you to coordinate asynchronous work across a bunch of different execution contexts, as well as you could start getting into emerging proposals, such as shadow realms, to allow you to better compartmentalize code, or compartments, which also deals with compartmentalizing code. And then finally, you could talk about the HTML sanitizing experimental API that's making its way to browsers. So that way you can evaluate untrusted HTML and put it into your web page without having to worry about opening up any security vulnerabilities. And so just by kind of tugging at the thread of this one API, we can start to learn a whole lot about the web platform. And along the way, we're also learning and picking up some transferable skills, transferable takeaways. Right? We talked about multi-threading, which is a concept that applies not just to JavaScript, and historically wasn't really thought about in JavaScript, but applies to a whole bunch of other languages out there. We also talked about execution contexts, or if you think about a more server-side application, maybe having different languages running alongside each other that are isolated and having to communicate between them. And so understanding these ideas allows you to transfer that knowledge into other domains that maybe you're not as well versed in, but you could still have productive conversations with people about them. And so this idea of kind of transferable learnings is, I think, kind of the second big reason why I really find native web APIs a really interesting and powerful area of the web to study. And to illustrate this idea a little bit more poignantly, I want to talk about an API that is in service workers that a lot of folks don't ever deal with directly. And that is the respond with method that you find on fetch events. Now, if you're not familiar with service workers, essentially all they are is a proxy that sits between your application and a server. And so it allows you to handle the response handle the request as it's going out, as well as the response as it's coming back in. And most typically, the way this is used is to allow and intercept requests. And instead of going all the way to the server, you can pull something out of your cache and then return it without ever actually having to issue a request to the server. And this is great for performance reasons, obviously. And I think this is the idea and approach that most of us are familiar with when thinking about service workers. However, there are other use cases for them. And if you read the spec, it actually talks a little bit about some of the ideas of other ways that you can use the service worker, as well as specifically this respond with method that happens anytime you make a request. And so caching network responses, that's the obvious easy one. But more interestingly, it allows you to kind of invisibly manipulate and transform any files or data that you're requesting from a server. And so you can use this to an interesting effect to do things like polyfill or create totally new file types that the browser actually understands, even if they're not natively supported, or do things like mock out non-XHR requests. So, maybe you want to mock out an image that you're loading or a script or something for a specific testing use case. And the way that this works is, based on the same principle of having a service worker that sits between your client and your server. But you got to start thinking about it from the website's perspective, and that is that's essentially a black box. And so if your browser were to say, hey, get me this image that's in an encrypted image format that web browsers don't actually support, we could actually make that request like normal, forward it onto the server, and then when it comes back, we could pipe it through a transformation function that actually decrypts the image, and then have the event respond with that decrypted image, and your browser will think it's just a normal PNG and will render it appropriately. Now, I think this idea is kind of interesting and allows you to explore a lot of unique ideas, but maybe more practically to a lot of us, if you work with TypeScript, is what if we could run TypeScript in the browser using the same idea? You don't have to run any sort of local server, and instead you could just have a .ts file being loaded up into your browser. Well, that idea actually works. And I put together a small demo a couple years ago showcasing this, where you can load an index.ts file and it'll just run transparently for the user. So you can find this on Glitch at typescript-in-browser.glitch.me. And it works. And basically what it does is anytime it compiles a TypeScript file, it caches it. And so the next time it loads, assuming the contents haven't changed, it just executes that same code again. And so this is pretty similar to how Deno works in theory. If you're not familiar with Deno, it's a kind of up-and-coming alternative to Node that has first-class TypeScript support that basically works on the same principle. Compile it, cache it, and then execute it. But we could take this idea one step further, right? And we could actually start using this, again, for kind of unique web application use cases, such as developing a plugin system that lives totally in the user's browser where they write TypeScript. And your backend wouldn't have to be complicated because you wouldn't need to do any sort of server-side compilation. You could just store that TypeScript file, and then users compile it and execute it in their browser. And so personally, I think that these ideas are kind of fun and interesting to play around with and potentially give us ideas for some unique development workflows. But I want to note that any of these ideas break the notion of progressive enhancement, which means that your service worker is no longer progressively enhancing the experience for users, but is becoming a core requirement of the experience. So you need to evaluate that and whether or not it fits your use case. And for most production websites, that's probably not the case. But again, throughout this journey, we've been touching on a whole lot of different concepts and ideas again. And so, we were talking about kind of advanced fetch concepts and how you can manipulate the response objects and return different data than what was actually requested. And if you go a little further, you might start talking about streams and the ability to kind of stream in the data from your request and transform it as it's streaming in, rather than waiting for the request to complete. You could start talking about web cryptography, if you wanted to do things like the encrypted image format that I talked about. Or maybe you start talking about decompression and compression on the client using a new API that's being built, so that way you can do things like gzip data without actually having to import a custom library to do it. And all these ideas, again, roll into a whole bunch of transferable skills that you're learning as you explore these concepts. We're learning a lot about network request and response handling from the browser's perspective. You can learn about caching and how to invalidate the cache. You can learn about all sorts of different file formats, whether it's image formats or just how do you compile TypeScript. We can learn about streams and streaming data. And then we can also learn about graceful degradation, which is kind of the opposite of progressive enhancement. So if you were to ship something that relied on a service worker, what is the user experience when it's not available? And all of these ideas are transferable to other programming languages and other programming paradigms and domains of development. And so at the end of all of this, it enables you to have better conversations with your coworkers, whether they're back-end workers or maybe even folks that are coming from machine learning or data science backgrounds. And I think in general, it just gives you a more creative viewpoint of how to use the web. And you can start using these APIs that people usually use for pretty, traditional and standard ways and more interesting and creative ways. And so that's the last thing I want to talk about, is how web APIs can really enable you to come up with new creative ideas for what is possible on the web. And I want to talk about one final big API, and that is the audio worklet processor. So the audio worklet processor is a relatively new API. I think it came out like 2 or 3 years ago, or at least that's when it was finally rolled out to all browsers. And essentially, it's part of the web audio set of APIs that you find in browsers. And if you're not familiar with the way web audio works, it's pretty complicated. But if you have your website, you can set up an audio context. And then within that audio context, you can create a whole bunch of different audio nodes of different types. And so worklet processors come from this type of node known as an audio worklet node. And this node type is interesting because it instantiates an instance of an audio worklet processor. And the unique thing about this is that it doesn't run in your browser's main thread. In fact, it runs in a special thread known as the web audio rendering thread. So this is another case where you're dealing with multi-threaded JavaScript and not blocking your browser's main thread. And so within this processor, you can write your own custom processing logic to deal with any sort of incoming audio data. And so essentially your audio source pipes in data, and then after it does all the processing, goes through all the audio context nodes, it eventually gets output into your browser's speakers. And so I think that this is a really fascinating realm and unlocks a lot of creative ideas, potentially, if you're interested in audio stuff like I am. The problem is that it's pretty hard to find good examples online, and so you're going to have to kind of really dig at it if you're interested. And so you might ask yourself, once again, why would we actually need this? Like, what practical use cases are there for having to write your own custom processor? Well, the first one, most simply, is just to do custom signal processing and do things like add custom audio effects. So maybe you want to write your own interesting distortion effect for any incoming audio signal, or something that makes it sound like an anime character speaking. Those are ideas that I just drew from the guitar pedal world. And so you can start building guitar pedals into your web browser effectively. Or maybe you want to do off-screen or off the main thread audio visualization. And so you can actually connect to that web audio rendering thread and take the data, pump it out to a web worker, which is not on the main thread, use an off-screen canvas to then draw to a canvas without ever actually having to touch the main thread. So you can have a really complex and algorithm-heavy visualization going without ever having to put that logic and computing power onto your main thread once again. And then finally, maybe you just want to make some cool, interesting custom noises. This is actually how I've used it in a personal project. Basically took that diagram from before, didn't hook up an audio source to it, and instead wrote some custom processing logic where all we did was basically just generate a bunch of random numbers. And effectively what this does is it creates white noise, which to most people just sounds like static. But there's an interesting way that you can use white noise. And I used it in an application that I maintain called deepbreathing.app, which is a pretty simple application that just has some deep breathing exercises to help folks dealing with anxiety or any sort of mental health issues and kind of just calm yourself down, basically. But on this website, I wanted to add smooth brown noise rather than white noise. And so brown noise is something that's kind of been emerging in recent years as a spectrum of sounds that helps you tune out other things in your environment and kind of gives a little bit more focus and clarity to your thoughts. And so the way I was able to do this is by leveraging all the stuff that I've talked about thus far, but then within the audio context, doing a bunch more to kind of shape the sound that I was getting. And so you could pass your brown or white noise signal through a low pass filter to kind of, get rid of some of the super bassy tones, and then run it through a high pass filter to get rid of some of the very harsh upper tones. And then you could run it through a gain node finally to actually make it sound at a reasonable volume. And so what you get at the end of this is you get a new sound profile, which is brown noise. And then you could go even further and do a lot more complicated things, such as introducing a oscillator node to kind of modulate a value, and then using another gain node to amplify that value, and then connecting that to something like the frequency of your low pass filter, so that way it kind of changes the frequencies that it is or is not cutting off, and it gives it a more organic, almost wave-like feeling in sound profile. And so you can take these ideas and add tons more nodes and do a lot more interesting things, and eventually you can wind up with a sound profile that's totally unique, and most importantly, totally copyright free, and you don't have to ever pay out any royalties or anything, and each user can just turn it on and let it run indefinitely. And so that was the use case that I had in my app. And along the way, what it allowed me to do was develop this kind of immersive experience for folks that were using the app. Rather than just looking at the screen and seeing the visuals on the screen, they could now also have an auditory experience while they were doing these deep breathing exercises. And while I was implementing this, I learned a ton, but also had to brush off some old skills that I hadn't used in a while and do some cross-browser debugging, because Safari doesn't quite support all the web audio APIs the same way that Chrome does. And so that was really frustrating, but it helped me exercise skills that I hadn't used in a while. And so once again, as with all the other things I've talked about, we learned a ton of different topics along the way. We talked about web audio APIs, we talked about web MIDI, or we didn't talk about, but you could dive into talking about web MIDI. You could talk about the media captures and streams API for if you want to take in input from a microphone or some other instrument. You could start talking about the permissions API and how you actually grant or get permission from your user to access those things on their device. And then you could even start talking about things like the vibration API if you wanted to connect that auditory experience into something that is also tactile in nature. And then finally, learn some transferable takeaways once again. Talking about audio concepts, which has a lot of different applications depending on your field. Talked about signal processing, which, while most commonly used in audio stuff, also has applications in other fields. And then we talked about, once again, input devices and hooking up to different input sources for audio. And then we revisited a whole bunch of things that we've already kind of talked about: streams, threads, file formats, etc. And so at this point in the talk, you might be saying to yourself, okay, that's really cool, so what? But right, most of these things aren't stuff that we're doing in our day jobs. Everything that I talked about is stuff that I mainly discovered in my side projects. And I think the so what is that by really learning about and understanding what the web platform is capable of, you can start to shift the way you think about architecting web applications, right? We're not limited to one thread. And in fact, we're not even just limited to using one thread in web workers. There are all these different technologies that have come to web browsers over the last year that enable us to build much more complex applications with the end goal of providing a better experience to our users, whether that's through making their experience less janky and less slow, or by just adding new creative elements such as visualizations or audio, custom audio generation. They also really help us unlock creative ideas, right? Because anytime you encounter one of these APIs, you're asking yourself, okay, why would I need that? And all of a sudden you're making yourself think a little bit more creatively about how you might use the web platform. And then finally, kind of bundling all those things up together is that web APIs can really help us unlock a new perspective about what is possible on the web. Right? You ask yourself, why would I need that? But then you might also ask yourself, okay, well, what else is related to this? And before you know it, you've gone down this deep rabbit hole and have learned all sorts of things about the web and the web platform that you previously didn't know. And then maybe you get to the end of it and you've actually learned transferable takeaways and ideas that you didn't previously have. And now you can communicate more effectively with other web developers as well as with people in other programming domains. And then if nothing else, it will help you do better at JavaScript trivia. And so I hope you walk away from this talk realizing that web APIs can really help us restore the joy of developing for the web and give you a lot of creative power to build things that are interesting and unique. So my parting thought for you all is, what are you going to build? Thank you. So Canvas fits in probably a lot of different areas. I mean, I couldn't do an exhaustive list because we would have been up here talking for a long time. I think the Canvas API in the browser is really interesting and I think has evolved in a lot of unique ways to do things like, support WebGL rendering, or like I mentioned very briefly, support off-screen algorithms so that way it's not blocking the main thread. So yeah, Canvas, definitely a huge avenue for creativity on the browser. Yeah, good question. So when to look up a web API and see if that capability exists versus, finding it in a library. Honestly, I just Google things. And half the time, if the web API comes up first, that's the rabbit hole I go down. But if a package comes up first, that's probably where I'll actually go. And I think the way that I combat this is every now and then, I straight up just go to the MDN's page for web APIs and scroll down it and read. And there's so much interesting stuff there. And it's a great way to really expand just your knowledge of the web platform in general.
I was going to add, yeah. MDN is huge that way. A lot of times you'll want something in a web API, like Gap from CSS Grid was missing for a long time, but it was in CSS Grid, but it wasn't in Flexbox. And one day I was like, I wonder if they have Gap, and it was just there in the API. I was like, huh. And it was supported everywhere, and I introduced it, and my co-founder was like, when did they have that? I've been waiting for that for years. And so sometimes things really just sneak up on you, and MDN is by far the best resource to find what's currently there and what's supported. So yeah, it's cool. Anyway. All right, thanks, Trent.